Hi, my name is Heng. I'm a battery scientist and co-founder of CamVolt. Here, we enable our clients to apply optimal stack pressures on their pouch cells with high-quality and cost-effective instruments. For the past few years of my research, I've been deeply involved in projects focusing on understanding how external stack pressures impact battery performance and degradation. And what I've been finding is that the pressure has this huge but poorly understood impact on battery performance. Despite this, there's a lack of readily available equipment for precise pressure control designed for batteries. And consequently, researchers and material developers often find themselves having to make an estimation of the pressure applied and hoping it was even. When we are talking about the technology that renewable energy transition hinges on, this black box surrounding such an important variable is alarming. That's why I teamed up with my co-founder Joe to end this pressure guessing game once and for all.
When Heng started talking to me about the difficulties of effectively testing the impacts of pressure, we began working on this problem together and realized that with a bit of clever engineering, we could create a solution. Traditional pressure rigs often use rigid plates held by bolts or foam-based stacking, which results in poor control of precise and accurate stack pressure, especially during the formation stage of batteries. Pressure is often applied and calculated by tightening a bolt with a torque wrench in an uncontrolled way that leaves researchers unaware of what pressure they really put on. In contrast to the current methods, our equipment offers an accurate solution for testing with a controlled pressure.
When Joe and Heng approached me with their product, as a chemist and materials scientist in the battery space, I immediately saw the importance of such a product for accelerating battery R&D. Because for rechargeable batteries, applied pressure is one of those puzzle pieces that hasn't really been cracked. You just see a lot of trial and error, and consequently a gap in the fundamental understanding of how to find the optimal pressure for a given cell chemistry. And when we're trying to rapidly improve this technology that's supposed to, electrify transportation and store renewable grid energy and decarbonize who knows how many other sectors, you want to have all the answers.
So, what is the big deal with having that optimal pressure? Well, batteries are complex systems where materials, mechanical, and electrochemical properties are tightly intertwined. Pressure plays a big role in three ways: by changing the electrochemical impedance, by influencing cell reactions, and by adjusting mechanical response to internal stresses. The impedance refers to the resistance that ions and electrons encounter as they move between and across battery electrodes. It impacts properties such as specific power, effective capacity, and heat generation, which could impact cycle life. When the right pressure is applied, it can lower impedance by improving electrical contact, enhancing electrolyte wetting, and reducing diffusion pathways. Pressure also impacts side reactions and structural response to internal stress of the batteries. An appropriate stack pressure helps remove gas bubble during the formation and prevent heterogeneity within the electrodes. It also protects the electrodes against mechanical degradations, such as structural exfoliations and delamination from cycling-induced volume changes. On the flip side, too high stack pressures can introduce risk of poor electrolyte infiltration and contribute to particle cracking, which will shorten battery life. Ultimately, identifying the optimal stack pressure is a balancing act complicated by materials and manufacturing variances. Here at CamVolt, we believe that for a technology as pivotal as batteries, a pressure guesstimate is no longer good enough. Material developers and pouch cell users need stack pressure that is applied evenly, reliably, and accurately.
Our solutions address the current gap in the market by hitting the mark in three key demands for testing the impacts of pressure on formation and cycling. First, our pressure is known. Our pneumatic method for applying pressure to cells loads pressure with an accuracy of plus or minus 1.6%. Second, our pressure is repeatable with an accuracy across repeated tests of plus or minus 1%. You can be sure that when you use our press, pressure is not your changing variable. And finally, our pressure is even, designed to fit your pouch cell batteries perfectly, ensuring that homogeneous stack pressure is maintained across cells. We take care to talk to each of our clients and ensure that we understand their batteries and how to ensure the pressure across them will be even. Our team of engineers is constantly working to develop new solutions that will improve battery R&D. If there's a battery R&D pressure you have, reach out today. So why wait? At CamVolt, we're on a mission to accelerate battery R&D by making better data possible. Join us and let us help you develop the batteries the world needs today.